So now we're recording the presentation. It does just record the screenshot and the audio. So any video, pay extra close attention to and burn that in your brain. So without further ado, I will turn this over to Kurt Ferguson. And just again, please chat any questions that you have. Take it away, Kurt.
All right, good morning, everybody. Carter, for the intro. Hopefully everybody can hear me okay. If you can, please drop something in the text box for Carter to investigate. But thanks for taking the time to join us. As Carter said, I'm Kurt Ferguson. I'm our regional guy here out of Houston. Going to be talking today about Turck's process wiring. Over the past 13 years, I've mainly given this presentation in person. This is one of the first times I'm doing it virtually, so I'm used to lots of feedback and oohs and ahs. So if there's any comments you want to make or any praise you want to give, which I thrive off of, please drop that in the chat box. The other thing is, if you've got me on a separate monitor and you're doing other tasks, I completely understand. We're all in weird times, but hopefully some learning by osmosis will occur. So if you will, I've got my Mr. Rogers GIF up there. I've already got my sweater, my sneakers on. So we're going to go down the pathway of process wiring. So I'm sure some of you have seen what's on the monitor there before, which is what's called a poured. Poured seals have been around forever, and those are there to function in explosion-proof applications as gas blocks. And they're still around, they're still used tremendously, but we kind of consider them a thing of the past at Turck. We want you to move into the future of process wiring, which is what the purpose of this presentation is today, is to convey what that future looks like and how it can potentially apply to your products or your applications or your equipment that you're manufacturing or having to support. So moving on, what is process wiring? Process wiring are quick disconnect products designed specifically for the special need of process automation. And when I say process automation, that can be any kind of process. It could be manufacturing crude oil, or processing crude oil. It could be processing gas. It could be making pharmaceuticals or cosmetics. It can be a variety of different topics. So process wiring fits in all those markets. So hopefully one of those deals with what you're working with on a daily basis. So the benefits of process wiring, it kind of came from the factory automation world. And anybody that's been in factory automation has dealt with probably M12 quick disconnects, or if you're used to Turck, we call them Eurofast. Those are plugs that make the speed and ease and cost of installation very low, because you can go deploy equipment very quickly on your pieces in the field. It's generally reconfigurable, which means you can unplug things, move it around, plug things back in, replace sensors very quickly. And most of the time it's mistake resistant. And what we mean by that is, by using pluggable devices all the way from your control panel, it's really hard to mess up wiring. As long as you've got it landed on the right terminal block inside the control panel, you should be good to go 99.9% of the time. There's always that one outlying factor, but it does make it as close to mistake resistant as possible. When you take those attributes and you apply them to process automation, there's even more benefit to it. A lot of times in process automation, you have to deal with frequent calibrations of equipment. There's maintenance. Things have to be pulled out and replaced and put back in, sometimes because of corrosive environments or things of that nature. A lot of times we're dealing with skids or modular construction. What that means is, let's say you're building a skid on site that has to connect to another. Well, you've got to break that down to ship it, because most times you can't fit one skid on a truck. So this allows you to plug and unplug those devices. So once you do get on site ready to deploy, everything plugs back together. You don't have to spend a lot of time rewiring. There's a wide use of field bus in our industry. That could be foundation field bus, Profibus DP, Ethernet now is becoming more and more prevalent. So being able to be rated for those hazardous areas and provide communications is key. A lot of times we replace more expensive wiring methods, and a lot of times that expense is tied to labor, of having to go run pipe or pour seals or pull wire. We can get away from all those tasks with our process wiring connectivity. And most of the time in our industries, the products that are being manufactured are very high value. And that's key, because we've got to stay up and running. If you're running a a pharmaceutical process that's a very expensive medication, you can't afford for that process to go down. So by having a mistake-resistant product offering and wiring, it helps keep your line up and going where you're not doing constant replacements or having to take your line down. Here's just an example of an application that we've had where frequent calibration came into play. This is actually from the Alaska pipeline, and it's an application on a LACT unit. And for those that aren't familiar, LACT is local area custody transfer, or basically the cash register on an oil or a gas pipeline. Well, as you can imagine, that flow meter that's on there, it's got to be calibrated fairly often because people want the right amount of money for the product that they're producing. Well, to go pull that multiple times, if you didn't use Turck process wiring, that means you have to go break a seal. There's a lot of mechanics involved to take that flow meter out, versus with process wiring, you simply go, make sure your circuit's disconnected, unplug it, put the new calibrated unit in, plug it back up, and you're up and running again. So your downtime is cut down considerably. So that's just a key example of where frequent calibration, your life can be made easy by using Turck process wiring. So in our world, what are the challenges that make our world special? Obviously, harsh environments. This is a picture I found online. I'm assuming that's something in the potentially just based on the amount of ice accumulation on the rails there. But that's the world that a lot of us live in, especially on the oil and gas side. Petrochem, you're dealing with events like Hurricane Laura that just came through in Louisiana. That's coming through and wrecking processes. With Turck process wiring, you're able to get back up and going much, much quicker because of the sealed environment of the connectivity. Since it is pluggable, it's IP67 at a minimum, which means it can be in a meter of water for 30 minutes without any kind of water ingress. We've seen it much longer than that be able to go, but it does give you that protection. Obviously, chemical manufacturing has its challenges, pharmaceutical, which I just mentioned about, and then water, wastewater, because we all know if water and wastewater isn't functioning, society is going to be quickly going to a spiral. So it's key that that stays functioning. Also, another challenge in our environment is people are wanting to run these networks, foundation field bus, Ethernet, things of those nature. Well, oftentimes shielding and very high level shielding is required because of the power that's being used by other pieces of equipment around it. So we're able to provide that extra shielding. And then also you've got NEC compliance that you have to adhere to, and then also hazardous areas that you have to take into consideration, class 1 div 2, class 1 div 1, even some zone ratings if you're going into Europe or throughout the world. So based on that, let's jump into a little bit of NEC. And as exciting as code is, it is important to talk about this. So NEC compliance for class 1 division 2 areas. So telling a little story, in 1996, the NEC instrument tray cable, or you may have heard the term ITC before. Since then, since 1996, they've actually expanded how you can use ITC cable as a division 2 wiring method. So what Turck did is Turck took the concept of ITC cable, coupled it with our quick disconnect product offering, got certifications, and really revolutionized the wiring for hazardous areas. So building on that, nearly all process installations are subject to the National Electric Code. It's just the fact of the matter. Most of the time, circuits be wired for approved methods. All wiring media has to be rated. Even the raw wire used in conduit has to be rated according to NEC. And circuits that aren't like a class 2 circuit, and for those that aren't familiar, what class 2 means is the circuit is power limited to 100 watts at 24 volt DC. Even circuits that aren't power limited have to use a 600 volt wiring medium. So what that means is even if you're running a 12 volt signal, if it's not a class 2 circuit, you still have to use 600 volt wiring. Well, Turck, with our one major exception, and that's ITC cable. So what ITC cable is wiring for instrumentation and control where circuits are less than 150 volts and 5 amps or less wiring. I'm sorry, 5 amps or less of power being utilized. They can be used in cable tray. ITC cable can be used in raceways. There's armored ITC cable, which we're going to talk about here in just a second. There's also what's called exposed run ITC cable. You may have seen it designated as ITC ER previously. What that cable allows you to do is actually drop out of your tray up to 50 feet down to a device or a switch or whatever it is you're trying to route down to. The key caveat here is with ITC rated cable, you cannot run power circuits, you cannot run lighting. Caveat is with ITC cable, that is a requirement. So just looking here, here's the 3 examples, and we're going to delve into each one individually of the different types of ITC cable that's going to be available to you. The first is our standard ITC cable. This is going to be something that where you have to run the cable in tray all the way down to your instrument or your device on there. You know, it definitely makes life easier than having to run rigid conduit and deal with poured seals, obviously. But key is that tray does have to be taken all the way down to the instrument housing itself. The next generation of that was what I mentioned, which was ITC ER rated cable. So what that means is with the ITC ER, now you can run it in tray, but then whenever you get ready to drop down your transmitter, you can do that. You can run it in some angle iron, something to mechanically protect the cable down to your transmitter. So what that means is it doesn't have to be tray. It can be other types of mechanical protection, and you can take that out up to 50 feet from the tray down to your transmitter or your device. And here's an example of what that could look like potentially within a process installation where you've got some angle iron run and it's tied off and supported every 6 feet down to the transmitter in that case.
Hey, Kurt.
Yeah.
Yeah, I got a quick question here regarding ITC cable, and maybe you're going to get to this, but the question is, can we use 4 amps and 24 volt DC power with ITC cable?
Yeah, in those situations you can, as long as it's under the 150 volt and the 5 amp regulation on those guys. So we have seen some applications where you'll have lower power actuators, for instance, where they'll need multiple wires going out to them, but they're very low power. So you can have the power on there plus your low power control signals as well.
Thank you.
All right, I'll assume that was it. I'll move on. So ITC ER cable is a very high spec cable. Basic ITC is still a premium cable. It's got more restrictions than the ER version, and most cables now, especially that Turck has to offer, are going to carry the ER rating on them as well. So within the ITC ER cable, the crush and impact resistance and requirements are going to be extremely high and difficult to meet, especially for an unarmored in them. But the testing they have to go through in order to get that ITC ER rated marking is that the cable is crushed 10 times between a flat plate and a 3/4 inch rod, and the average force to produce an electrical short must exceed 1,000 pounds. So I know a lot of times in my career that I've dealt with, people are really worried about cables being stepped on. Well, using an ITC ER rated cable, that concern pretty much goes out the window. We've even had applications where we've had ITC ER cables strung across a frac site and had skids actually sat on our multi-conductor panel. Didn't realize it, ran the frac job, lifted the skids off, coiled the cable back up, went to the next job, and it worked fine. So it's a very, very rugged cable. For impact, it has to withstand a drop of a 10-pound ball 10 times from 1.5 feet. And out of those 10 times, at least 8 of those times, a short cannot be caused. So that just gives you an idea of the impact testing that it's got to go through as well. So a very rugged cable. But really, the biggest feature of this is it provides flexibility down to the last foot. You know, this is traditionally how this is going to be done, where you've got your rigid conduit run out to a point, and then you're going to have your flex going up, and then you've got your poured seal there functioning as your gas block to your transmitter. How we always recommend doing it is run it out there. You got your service sleep, you plug it in, and you're up and going. We're going to move on to the plugging. It provides that flexibility down to the last foot. So the one other type of ITC ER cable we mentioned briefly was an armored version. The nice thing about the armored cable is you just have to mechanically support it every 6 feet out to your devices. Other than that, no tray requirements, no mechanical protection requirements. Obviously, you've got the armament on there. You just got to support it every 6 feet. The one downfall to it is this cable, if you're one, this cable can be very heavy. The more of it you have on a spool, for instance. The other thing is it's not really made to be spooled and unspooled, spooled and unspooled. So that can be an issue if you do have temporary installations on this guy. If you've got a fixed installation and you don't want to run tray or any kind of mechanical protection, this is definitely a viable option. We have a variety of different cord sets that have this type of mechanical protection in it also. So great, the ITC ER cable is great. We've got a lot of different options, but we want to take it a step further. We want to go add what we call one of our receptacles to the device. So this is an example right here on the camera, if you can see it, of a 4-pin receptacle. It has a 1/2 inch NPT on the back of it. This is made to go be added to a non-incentive transmitter or switch, whatever you may have out here. You're going to screw that guy in, and you're going to plug in your ITC connector, or I'm sorry, your ITC cord set. What this means now is this guy has to be calibrated in the field. This guy has to be pulled out for a mechanical reason, whatever that may be. It's as simple as unplugging it, putting a new transmitter back on, plugging it back in. It does not take a certified electrician to go and swap these out now, be it in a pharmaceutical plant or even out on a wellhead. You can send anybody out there to swap those out for you. The one key caveat is, and for those that aren't aware, Class 1 Division 2 means a hazard should not be present under normal operating conditions. But what we all know is under non-normal operating conditions, a hazard could be present. Well, if you're allowed to simply disconnect this at any time as a hot circuit, you could potentially arc across those contacts. And if you did so, and just so happened gas was present, you could have a major issue at that point. So what Turck has to keep that from happening is our lock fast device. To be a tool to remove a protection device before unplugging can't be used in a Class 1 Div 2 area. So by adding this on and snapping it around the connector, it's there to force the technician to be reminded, hey, I need to go kill power to this circuit before I pop this guy off, right? And you can see on here, there's actually a label that shows it. And the lock fast is a very simple device. It's a clamshell. It's made to just go right there. And one of the questions I always get is, hey, if I take this off, we're just going to find them in the dirt. We do offer these now with a lanyard on them. So you can go and add a lanyard behind this guy. So if this is taken off, it can hang from the transmitter while you're swapping or doing whatever it is you need to do, calibrating, whatever that may be on there.
Hey, Kurt.
Yep.
So quick question. Somebody was asking if the plug also works as a secondary seal from the process or the temperature, or for temperature elements. It says works as a secondary seal from process for temperature elements. Is that correct?
I'm not. We'll have to circle back on that one. I've never been asked that question. I guess I need a little more clarification. Can you notate down where the question came from, and we can dig back into that a little bit?
Absolutely.
I know. Yeah. I don't know the answer to that one. We'll have to get a little more information, or if they can provide a little more information over the chat, as to what they were wanting to accomplish. We can.
You got it. Thank you.
All right, so just an example here of what a lock fast would look like. Again, it makes disconnection impossible on there, warns the user to disconnect power before removing. And you'll see actually from this next picture, here's an example of one right here. It says, caution, do not disconnect while circuit is live. If you've got your readers on or your glasses, you can actually see right here, we reference our FM control drawings specific to that. So where that's key is if you get an inspector in your plan or on your well site, and they're saying, well, you know, I've never seen this stuff before, not sure how it works if you're meeting code. This references directly to our control drawing, which shows how these can be implemented in the hazardous area in a safe manner. So you do have that protection there for you as well. If you need help finding that certification documentation, please contact your local distributor or Automated Dynamics guy, and we can help you find that documentation. Quick disconnect solution from Turck is, being that this is a molded connection over here, you do not need a boundary seal now when transferring from a Class 1 Division 2 area into a non-hazardous location. So where that's beneficial is, typically in the past, you would have to have a poured seal here at your transmitter housing to keep gas migration from going into the transmitter. You would also have to have a boundary seal here going into the non-hazardous location to keep gas from flowing potentially into your main control. Sheathed cable and a molded body here that is no longer required. So that's just another added benefit to using Turck's system and cut down on the amount of labor that it takes to have installations stay up and going. And then one other takeaway from this as well, and you know, obviously it was a terrible thing that happened over in Louisiana here recently with the hurricane. We all know, you know, the secondary function of conduit is in a big rain event, it turns into water pipe. Just or how good they think they've sealed up their conduit, it doesn't keep water out. So in this case, this is actually where a the water had actually drained into an actuator housing that's being taken off. So by using Turck's system, everything is completely sealed and watertight. You don't have this water migration issues that could potentially happen on here. So we've actually taken it one step further, and I know we're on to probably step 7 now from what I've said. I guess I've introduced what we call an explosion-proof feed-through. So what this guy is this is actually made for transmitters that get their, or switches, that get their rating for Class 1 Division 2 by being an explosion-proof device. So you've got two different types. You've got a non-incentive type transmitter, which doesn't require this type of receptacle. It can use one of our standards. Or you have an explosion-proof transmitter or switch where the housing is what gives it its approval for the hazard. A receptacle that's potted to the point to be able to withstand the pressure from a potential explosion within inside your transmitter housing. And then as that explosion occurs and the gases are outgassed through the as they're outgassed through the connect or out the housing, it cools as it goes across the threads leaving the housing. So what the key from this is not an explosion-proof connector. This does not allow you to disconnect hot still. You still have to kill power to the circuit before you unplug these transmitters. The key is it seals up your explosion-proof housing to retain the EX rating in that Class 1 Division 2 area, but now it is considered pluggable. Okay, so hopefully that makes sense. If not, we can get back into the weeds on it and we can hook up with one of your local guys. But it is made to seal up and keep your explosion-proof device.
Hey, Kurt?
Yep.
Got a question here about, does it provide H2O intrusion protection? Which I believe that's a yes.
On the threads or on the actual connector portion itself?
How about both?
Yeah, it should. It should. It should. I mean, obviously on the connector portion where the plug is occurring, from the cord set, yes, it does on there. As long as you seal your housing up correctly, just like you would with a plug, an EX plug or anything on the other ports, yes, it will provide that protection.
Thank you. And somebody's asking here, and I think the answer is yes, that what you're talking about right now with the explosion proof, that's what's called out by the EX in the receptacle part number, correct?
100%. Yep, that is exactly right. If you have one of our receptacles and it has an EX in the part number, it is one of the explosion proof feed throughs. They're typically about a 10 over our standard receptacles, but we do have some people that's what they standardize on, because then there's no question, depending on what the application it is, on which they're going to use. So, yep, that's exactly what that means.
Perfect. Thank you.
Here's just an example of a receptacle installed on a housing. You can see the wires pulled in and landed on the terminals inside. A close-up of one of the lock fast. Another way to tell if one of our receptacles is one of the EX versions is the receptacle will have the FM approval receptacle itself. So if you have one and you're curious, if it has that stamp, it's one of the EX. If it doesn't, it's not. And here's another example of it. This is an older picture from 2008. They put this elbow here. We do have right angle cord sets now that can plug this in and eliminate the need to put this elbow on there, just for your knowledge. Some of the applications, as I mentioned, explosion-proof limit switches, you can now make these pluggable. Limit switches wear out. It's just the nature of the beast. They do. They're mechanical. Very easy. Your transmitters, as we talked about. And then one thing I've actually done with a few customers is they've got a NEMA 7 box, which is explosion-proof, but they'll have IS barriers inside here. Well, for those that are familiar with intrinsic safety, it's power limited. So those circuits can be plugged and unplugged hot, because even if you arc across the contacts when you plug or unplug, there's not enough power there to blow the atmosphere. So what they'll do is they'll have a NEMA 7 box, IS barriers inside here, and then you now make those IS circuits pluggable. So again, a quick way, instead of having to have a bunch of glands on the bottom of here, and then you got to coil a bunch of cable up, you don't have to do that anymore. Now these can be pluggable if you're using intrinsic safety. And if you'd like more information on intrinsic safety, that is going to be one of the questions in the survey, is another topic for us to present on.
Hey, Kurt, quick question.
Yep.
Yeah, so kind of back to, I think, even using the lock fast, there's a question about the need to kill power. The question is, if a person were to verify the area is safe and no hazards are present, it could then be unplugged in a Class 1 Div 2 area without shutting off the power. Is that correct?
That's going to be more up to the... That's going to be more at the discretion of the producer or the operator at that point. All of our documentation calls out killing power to the circuit, and all of the verbiage that we call out has to do with disconnecting power to the circuit. So if you wanted to stay within the realm of the Turck documentation, you know, if they want to, if that producer or operator wants to make the choice to allow for a sniff of the area, to allow for it, that'd be up to them.
Got it.
So moving on a little bit, we've got an EX receptacle here, just a couple different ways. This is a Rotork actuator. They've got one of our EX receptacles here coming out. As you can see, it's mounted directly on the housing. This was how they had done it previously before this EX housing had come out. They had the elbow here with a... So what this shows is now by having our EX version, this work that was done previously doesn't have to be done anymore. Hopefully that makes sense. And then just here's an example of old and new technology. So the older port seals versions versus using Turck's connectivity. You can see mechanically much smaller footprint, so potentially smaller panels depending on what you're wanting to accomplish. So for those that aren't familiar with our product offering, these are Class 1 division. So what these guys do is allow you to bring in multiple control signals, or process signals, I'm sorry, into a single point, and then I have a multi-pin home run cable that runs back to your main control panel. So let's say you've got a wellhead that's got multiple devices on it. For instance, you've got some plunger arrival switches, pressures, whatever on those guys. you can wire all those into this one brick, and now instead of having multiple cables strung across the well site, you just got one cable that's running back. We can do this in an 8-port, or we have a 4-port version as well. We have some 6-port versions. We have some different wiring and some different pin counts. So we have had some applications where we've been able to combine a couple of actuators and some pressures into one of these. So if you've got an application, please get with one of us, because we can customize these guys. And if you do notice down here, this actually calls out all the certification documentation for these bricks, and they are certified for use with Class 1 Division 1 for intrinsic safety circuits as well. This is some gas well automation that we've seen. So you can see over here, we've got a couple of pressure transmitters where we're picking up values. They've got 4-pin cables on those that are running back to a brick on these guys. So in this case, they're using 5 of the 8 ports. You can see the caps that are on here closing off the others. They do come with plastic caps in the box. If you want to add metal, you can. But you can see back to your main RTU or whatever it may be on the side of the well pad. Here's another example of what was done on a wellhead where they had multiple devices. Again, plunger arrival, pressure. I believe even the ESD was wired into these guys. And this is a little bit unique and a little outside the box, because what was happening is workover rigs were coming in and pulling this wellhead, and they were just cutting all the cables and throwing it to the side. And so whenever they had to go reassemble the well, it took a. Now there's magnets on these junction bricks and this steel plate. So whenever they go to work over the well, they simply pull these bricks off, unplug everything, work it over, and then to reassemble, they just mechanically mount everything, plug everything back in, and they're up and going. So just a quick way, kind of to get these junction boxes out of the way and then get them back up on the wellhead.
Hey, Kurt.
Yeah.
A quick question, I guess, back on the junction boxes. If you've got those closure caps on there, do they need to have any kind of a snap lock on them? I guess that all depends if there's power on those pins or something.
Yeah, the only time you have to have it is whenever you're disconnecting on these guys. As you're pulling that out, you can see you've got your male pins on your receptacle and then your female contacts. Well, whenever that's disconnecting and you're taking those contacts apart, that's where you could potentially arc. On the closure caps, they're just screwed over the pins. I'm sorry, screwed over the overall housing, so there's no contact with the live pins on that. So no, you don't have to have anything on those.
Perfect, thank you.
So what we've got here, this picture is actually the bottom of a control panel. They've actually got a bulkhead plate, 2-pin home run bulkheads mounted. Slapped this on the bottom, wired it up internally, and then now all their home run cables from their junction bricks just plug directly in. So again, just ways to speed things up, ways to make life simpler when it comes to wiring of control signals, because as things progress more and more, and I know we're all seeing it, people want more and more information. They want more and more process values. So this is just a very simple way to help give them that without just adding a multitude of wires to your panel. So one of the other benefits to this guy is in a Class 1 Div 1 area, which is what we're showing here, as long as you're going intrinsic safety, right? You need a boundary seal going from a Class 1 Div 1 area to a non-hazardous location. So the benefit there is you're going from where a hazard is always present because it's Div 1 to an area where there should not ever be anything, and you don't have to do anything special to traverse from one to the other. So that's what this is showing. And as I mentioned, if you're using IS circuits, you can use our multi-port bricks. So now you can gather in your proxes, pressure transmitters, temperature values if you're using RTDs, clarify, and take those back to IS barriers on this side. So now you can go into the Class 1 Div 1 area and still have the same wiring process. It's just an example of an intrinsically safe tank battery. On top of there, this one's intrinsically safe. You can see we've got the blue cable here designating the IS circuit. Pretty much any cable that we have in a black jacket, we have in a blue for IS applications. Plugging into the transmitter housing. We've got a high level switch and a guided wave radar on top of each one of these tanks. You can see the cables routing out over here down the railway. Those are going down to a brick that's mounted somewhere below there. And then from that brick, it's going straight over to your control panel where your IS barriers reside. So a very clean way. And the only wiring you're having to do is from where that bulkhead right there is, you're wiring to those barriers from there. Everything's pluggable all the way to your transmitter. In our mini fast product offering, which is what we've been talking about here, 4/8 shielded twisted pair within a cable to be able to go and grab a multitude of devices. We've got our junction bricks, our cord sets, receptacles. We do have filled wireables. One of the things I always hear is, you know, these molded cables are great, but what happens if one breaks in the field? We do have field mountable options. So what that means is it's going to look like this guy, where the front looks like your standard plug, but on the back side, you're going to have screw terminals. So now if a cable gets cut, you can go and rework it on the side. In some applications, customers don't know their lengths of cables, so they'll buy one end with a molded connector on it and then use the other end with a filled wireable, depending on the application. One other unique product, and if we've got anybody here that's in a process plant versus oil field or equipment, is we have these conduit body adapters. So where these are neat is if you've got existing conduit, but you say, hey, I'd like to drop out of that conduit with the Turck connectivity to some transmitters because I'm constantly having to move them around. Well, we can do over your conduit housing. It's got a terminal strip on the back, so you can drop out of those guys and go directly over to a transmitter or switch or whatever it may be. This is just a bank or a battery of actuators where they're using some multi-pin Turck receptacles on there for control and power, turning these guys. But this is the beauty of it, is this panel showed up on site, all of these actuators pre-wired on there, so all they had to do once it's mechanically mounted is plug and plug, and they were off to the races. Contradicting myself here just a little bit, and if my wife was on here, she'd say I do it all the time, but we do have a power option. I know previously I said you can't run power circuits, and that was true because that was for instrument tray cable, which is designed for instruments. This is what we call our power fast offering. These are for power applications, and we use what's called tray cable, not instrument tray cable, but just tray cable in this case. We're going to have an A-size power, which is going to be similar to our A-size signal connectivity. Then we're going to have a D-size, which is actually 1 3/8 on this. Some typical applications for power fast are going to be on some choke valves, a lot of different pump applications, even if you got explosion-proof motors and VFD connections. I'm going to show you something here unique here in just a second that you can use for that application. But on our A size, you can get up to a 14 gauge, up to 15 amps, 600 tray rated ER. So tray rated cable, exposed run on these guys. It's going to carry a Class 1 Division 2 approval on it. You can do nickel, brass, or stainless. And then we'll bump to our D size after that, which is our 1 3/8 size. This guy, if you go to our 3-pin 10 gauge, you can actually get up to 30 amps across that line in a Class 1 Div 2 area. Nickel, brass, aluminum, or stainless, depending on the connector. I typically don't recommend aluminum just because it's soft. Stainless is where we live most of the time. You can see your approvals for sealing on this guy. We do T's for it. Where these T's are nice is if you've got a bus of power and you want to drop off to different motor, maybe you got some low power DC motors that you want to run off of these guys, like on a conveyor system in a hazardous area, you can do something like that. And again, these are going to have the lock fast just like anything else. To remind you, I'll definitely need to go kill power to that circuit before removing. Here's an example of where it's used on a Rotork actuator where it exceeded you know, the amperage limitations of our standard cabling. So this is, you're going to have your power connection here for your actuators. A lot of times these are going to be 3/4 inch NPT, which we can completely support. And then you got your signal connection over here on the other port. So your open and close commands, your feedback for open and closed on this wire, on this cable. This is a very prevalent application that we've run into more and more because of the ease of wiring on these guys, especially in the Div 2 area. So you can see for our cord sets, we can even do a right angle on the D size on those. The other unique thing for the D size as well is we can do explosion proof feed through versions, just like on our signal connectivity. So now you've got an explosion proof motor that's got to be pulled out periodically to have the bearings. You know, you're in a corrosive environment, it's going to have to be pulled out every once in a while. Now you can make those motors pluggable as long as they're below 30 amps and make that swap out very easy and get your process back up and going very quick. This is just an example of how it would have been done in the past, and I think this is that's actually the same picture as earlier, where you've got that standard explosion-proof receptacle, and then the old way of doing it with the poured seal and one of our standard versus the EX. Product that I wanted to make sure and point out to y'all that's now Class 1 Div 2 approved is a lot of times we run into solenoid applications where the solenoid is going to have an internal thread of like a 1/2 inch, and then there's going to be a couple wires coming out because this thing's Class 1 Div 2, so it's totally potted. Previously, if you wanted to make these pluggable, you'd have to add a conduit housing and then add a receptacle, butt splice them. Just a pain. Well, now Turck's come out with this guy where this back portion that looks like this can be threaded into the solenoid housing. You pull the wires through that guy and then land them on this filled wire bowl at that point. So now this has become a pluggable item. Very simply, you got rid of the conduit body and all that extra labor. It's a way to make solenoids quick disconnect, and even some limit switches that are potted quick disconnect very easily. Another issue that Turck confronted that we developed product for is the ability to make a quick disconnect in a C1D2 area. This is actually going to be a thermocouple receptacle with all the necessary wiring parameters for thermocouple wiring, no dissimilar metals. This is some of them installed, so you can see you've got your traditional housing here with your thermocouple going in. Normally in the past, there would be you'd have to run thermocouple wire into this guy through a gland or something along those lines, land it on the terminal strip. Well, now with our receptacles, you can screw that into that 1/2 inch NPT, land them on the terminals, and now these are pluggable. They're items. So this makes swap out of those very easy. And again, you know, I'm a simple man. We like to make life simple. You can take in up to 5. This shows a 4-port. You can actually take in up to 5 different thermocouples into one of these guys, run that back to your main control panel, and plug those in. That's all it takes. Something new for us as well is, let's say you don't want to go intrinsically safe because you just don't like the content, provide you enough power for your device. We've got some products now that can go into a Div 1 area. Turck has actually come up with what we call our MCHL cable. Traditionally in the past, MCHL is metal-clad hazardous location cable. It looks something like this. If you've ever seen an oakenite cable that's got the metal, corrugated metal all the way around it, this was an MCHL cable. This was the type of cable that you had to use in a Class 1 Div 1 area. It's very tough to work with. It doesn't bend well. If you cut it, it's very sharp when you're working with it. So Turck developed a cable that meets the same specs as that's non-armored. So this is that cable, and you can see the pliability of this guy now in a Class 1 Div 1 area. So you can do a couple different things. You can either extend from a Class into a Class 1 Division 1 area. This is a poured seal that we've already done for you. This is a rotary union that screws in here. So now you can screw that into your transmitter, wire it up. We build this as long as you want to extend into the Class 1 Div 2 area, and then you use our standard connectivity at that point to extend back to your control panel. The other option with this is if you want to go, for instance, from transmitter to transmitter or explosion-proof housing to explosion-proof housing, we can provide it with 2-poured seals on it. We build the cable in between as long as you want, and then it's got the 2 rotary unions on this guy as well. So a Class 1 Division 1 wiring method that's not your traditional Okanite, you know, go beat your head against the wall trying to bend the stuff and get it where you want it to go. We can make it very easy. The key to it is, find my mouse here. If you read it for an NEC Zone 1 505, it allows it without any kind of special restriction to use that cable. For NEC 500, which is going to be the Division 1 certification, it calls out where flexibility is required. Again, that's NEC being a little vague. So if there's a reason you need this pliability for your installation, then according to NEC, you're good in the Class 1 Division 1 area. Just want to make sure and point that out. There's a tank battery application that we've done with this. This is a legacy product of the same family. You can see it used to have the corrugated armor on it. We've done away with that now. But it's a tank battery application where we're gathering in multiple signals. In this case, they're wired to a Vega transmitter on top of the tank. This is a Class 1 Div 1 area. It's an explosion-proof Vega. You've got your rotary union portion going over to the railway, wired into conduit. That's how they chose to do this installation. In this case, you've got another transmitter on top. They're actually wiring on. At that point, they're going to one of our junction bricks and using standard Class 1 Div 2 wiring down to the bottom of the tank battery.
Hey, Kurt.
Yeah.
There was a question about the electrical current limitation on that EXG style method. I
don't know. I'd have to go dig that out. I can't remember that one off the top of my head. So the actual limit on the current carrying capabilities on that?
Yes. And would that depend on whether you, I guess if you had a mini fast, you're limited to the connector, but if you were going transmitter to transmitter, then that might apply even a little differently.
Yeah, I know if you're going from the Class 1 Div 1 to the Class 1 Div 2, you're going to be limited the same as you would on a standard ITC ER application, which is going to be 150 volts or 5 amps or less on that guy. Let me do a little bit. Can you note down who that was from? And I'll include that in the follow-up email we send out to everybody.
Absolutely.
Okay, thanks. So moving from there on to, everything we talked about so far has been Class 1 Div 2. I've spent the last 13 years working a lot on oilfield equipment, which typically means we're going global. So that moves into ATEX and ICEX, which is going to be basically global approvals. ATEX normally out of Europe, ICEX really came from Brazil and Australia, I believe is where it started, but now it's considered a global standard. But we have what we call our mini-fast HD design. And what that looks like, our cables would look like this, where it's got the mold on the back and then the rotary coupling nut. For the ATEX and ICEX rated product, it's an all stainless steel housing now on that guy. So instead of having that mold, it's actually a full stainless steel housing. So to get the IECEX approval, Turck actually had to go through all the ISO certifications to make it where our North American plant can build to IECEX standards. Basically, all of our certs are through FM for ATEX Category 3, outside of the U.S., IECEX Zone 2. We talked about NEC 505, which is the zone classification for North America. It'll be Zone 2. Then it's also Class 1 Division 2. So the reason I bring this up is if you're building equipment that's got to have a global certification on it, we have that now with this product. You can do 2 up to 19 pins on this guy. We only have them in a straight style. We don't have them in a right angle, and they're all going to be unshielded. And what that can be shielded cable, and it can be tied to a pin. The shield can, but the shield cannot be tied to the coupling nut on this guy. We're going to have all the same types of junction boxes that we have available for our standard C1D2 product. We're going to be able to do in this Zone 2 rated product as well. And you're going to use the same lock fast as you've used traditionally. Now our lockfast have all the approvals printed on the label. Just an example of that zone application. You can see the bodies are going to look a little bit different. They're going to stick out a little bit further. If that is a requirement of an application, please get with one of us. We can help you come up with a bill of materials to meet your application specs. So all that being said, this is the wrap up to it. In order for Turck to be able to meet all these approvals, we had to develop a cable that could go global. So that's why we developed our Extreme Life 60 cable, which we call our super cable. It's going to be approved for Div 2, Zone 2. It's going to carry some offshore approvals, 60 cold bend and -40 cold impact, which I'll tell you, I don't want to be in either one of those, but if your cable resides in those areas, this cable is going to be rated for it. It's going to have superior strength, crushed impact resistance. But the key is, for us to meet all these global approvals, we had to meet some serious flame retardancy guidelines. And FT4 being one, but the key is being this IEC 60332-3-22 spec. And this is what that flame test looks like. It's a 40-minute flame test that we had to go through and pass to be able to say we can work in Zone 2 areas. So it's hard to see, but this is actually the cable internally that's being burned for 40 minutes. And I was talking to my counterpart, Drew. He was saying this is actually about a 10-foot flame. So it's a very stringent, very strict test that we had to go through to get that cert. On this platform, we can support networks. So we can do Cat5. We can do J1939 application. We have some of these already created. If not, we can create customs as well. If you like the properties of the cable, 1,500 meter minimum, we can go create that specifically for you. And I don't expect everybody to, I think this is more of a marketing slide, but this shows just a little bit of everything about all the different certifications that this guy carries, which is very impressive for a single cable. The one key we've been able to do is we've consolidated a lot of our cable offering to this EX60 platform without even knowing it, because we have really tried to consolidate, which has brought the cost down on this considerably.
Hey, Kurt.
Yeah.
We got a question here.
Okay.
Why do we need seals on the connector if the transmitters are intrinsically safe?
So if you have an intrinsically safe transmitter, right, and I assume you're talking about the seal like a boundary seal, where that would traditionally come from is if you were using conduit, for instance, even if your device was intrinsically safe, you've essentially got a pipe from the hazardous area. If you don't have a seal, that means that gas could flow into the non-hazardous area through your conduit. And then if you've got a contactor or some kind of arcing device within that control panel, if you get enough gas accumulation within it, that could explode at that point. So the reason you need a seal is to keep the gas migration potentially from inside the conduit into the safe area. So with Turck, by using the molded connectors, you have the seal already at the cord set, because it's, as long as it hasn't been penetrated somehow by being cut or something along those lines, it's completely sealed so that gas cannot pass into the safe area from the Division 1 area where your IS device will be located. Does that make sense?
Yes, did to me. Thank you.
And again, on any of these points, if you need further clarification, feel free to reach out to any of us, please.
So if, I guess there was a follow-up that if we're not using conduit, gas cannot pass.
Connectorized system like ours, correct, the gas will not migrate through the cable.
Got it.
So for my offshore friends that may or may not be on here, Turck has recently released our offshore approved low smoke zero halogen cable called Extreme Life 70. I've got an example of it here. Again, a very pliable cable. This is actually going to be rated -70 cold bend, -40 cold impact. A 606 rated cable, which means it's rated for oil and mud resistance for offshore platforms. So again, we can utilize this EX70 cable on the Minifast HD product offering and give you a globally certified low smoke zero halogen cable assemblies now that you can use on rigs or any type of application that call for a low smoke zero hal designation on these. And for those that aren't aware, and I like to show this slide, and I'm almost finished here. If you ever need these from Turck, this is an example of one of our bulk cable drawings, and we have this for every cable we sell. What's nice about these is it tells you everything about it, all your mechanics of the cable. It tells you any type of gauging or shielding. It also tells you certifications. If it's a network cable, it tells you the impedance. And it also tells you down here any additional certifications it has that aren't already listed up here. So purposes, please reach out to one of us and we can get this for you. But other than that, I think that's the end of my presentation. That is the end of my presentation. So I will stop sharing my screen. We can stay on for a few minutes for any additional questions y'all may have from us. But if not, I'll let you take it from here.
Yeah, I've got one application question I was going to get to here in just a second. Since we're at our 11 o'clock, wanted to thank those who need to pop off. Thank you very much for attending. Like I said, we are going to stick around. I want to make sure all the questions do get answered. Talk about applications. If you've got any deeper discussions you want to have or applications, please get with whoever invited you or the ADC regional person in your territory. And if you need to know who that is, just send me a note. I'll make sure somebody gets in touch with you. We do have another one of these presentations today at 2 o'clock. So if you've got anybody that at your company or that you know of that would benefit from it, please do encourage them to sign up. I did put a survey in the chat box, so please click on that and just take a minute to fill that out so we can continue to improve. Otherwise, you'll see a follow-up email that will have the presentation, the recording of the audio with the screenshots and so forth. So if you got any other questions, please go ahead and get them typed in. The one application question we were going to ask here, Kurt, is in a Modbus application. Let's see here, where we're daisy chaining RS-45 devices with our Minifast. What is the typical Turck connectivity approach to that? Do we use like Y fittings at the transmitter, something a little more cost effective or common? What do you say about that? Uh-oh, I can't hear you. Did you mute?
Sorry, yeah, I muted. There was a couple of cats fighting outside my office window, so I muted. That was a joke. Sorry, bad one. We'll typically use like the 66D configuration, which means you'll have 2 shielded twisted pair, and then also a drain and a ground, and then we'll use the T's to split off those to multi-drop to the Modbus devices. Standard on how we do that. The Y fittings are great if you need if you want the EX housing and you want it mounted directly on the transmitter, but typically we'll just use a 6-pin T to make that happen.
Sure. And do you see both true daisy chaining as well as what turns into parallel wiring when people are doing something like that?
I haven't seen a lot of daisy chaining strictly because if they've got to replace a transmitter, it's more work.
Yep.
Where versus replace a transmitter, it's just the one device they pull out and plug a new one in. So that's what I've seen typically is the drops, not really the daisy chain. Drew may disagree with me. I think he's on here as well, but that's typically what I've seen.
So we've seen people do many things, I guess, when it comes down to it.
Whatever your heart desires, we can help you make it work.
Yeah, so if we're doing Class 1 Div 2, then it's a full Minifast solution. If your transmitters are, in a C1 D1 area, and I guess they're explosion proof, then I guess you can do the receptacle extenders to maybe get your, out to the C1 D2 area, so then you can use the T system and do the connectorization. Yeah,
absolutely. We have that 2-pair set up in an EXG. So yes, to answer your question, you can totally do that because we have the EXG with the 6-pin rotary coupling nut on it, so you can screw that directly into a T in the Class 1 Div 2 area.
Got it. And then the question's coming back about examples or diagrams for the daisy chain examples. I do believe some of our guys have put things together like that.
I think Drew has a pretty good example. We'll try, if you're still making notes, we make a note and we'll include that in the email we send out.
Absolutely. And Andrew, we will get some information to you. All right. Let's see here. Looks like I got a follow-up conversation that we'll have with one of the customers. We'll get some information, here for the daisy chaining. Looking for any questions that I might have missed. Let's see here. Will this video recording be available for download or sharing? The answer is yes. We will get the video put together and sent out as a link. What we've been doing is just putting that on a YouTube link and sending it out. Just so you know, the screen is what gets recorded as well as the audio. All of Kurt's fantastic hand modeling examples on his camera, those aren't going to show up, but you'll get the screenshots of the presentation and the audio. So yeah, you will get that in a follow-up email.
Any of our counterparts can come out and do the hand modeling as well. That's not a problem.
Absolutely. Let's see here. C2D2, is that pretty much treated the same as C1 D1?
No, Dino, class 2 div 2 is going to be class 2 is going to be it's not fibers and flyings, it's
grains,
dust. Golly, yes. Thank you. Dust. Yes. Yeah, I'm drawing a blank. Yeah, Dino, if you're still on here, class 2 is dust. And then division 2 is hazard should not be present under normal operating conditions. So no, it's not the same as C1, D1. They're two totally different things. But if you've got an application, you and I can discuss, what it would want to be. Now you could go C2, D1, which is going to be class 2 division 1, which is dust, where a hazard is always present. So you could do something like intrinsic safety in that case. To meet that area demand. But yeah, if you got an application, man, holler at me and we can go down that pathway.
Excellent. Well, just doing some time killing chit chat here, just in case somebody asks any more questions. Kurt, I really, really appreciate you doing this. It's obvious, the knowledge that you have in this. Thanks for a great presentation. Everybody that's still hanging on, thank you so much for investing the time in this session, and hopefully we'll continue to bring you guys some great value. And please, if you have any applications, just reach out to whomever invited you or any one of us, and we'll make sure you get taken care of. And with that, we got several thank yous on here, which we appreciate, and it looks like all the questions are taken care of. Oh, what do we got coming in? One of my customers who's pretty funny. That's a private one. Never mind. All right. Well, Kurt, thank you very, very much. Yep. And look forward to seeing you around 2 o'clock.
All right. Appreciate it.
Have a great day, everybody.
Thank you.